Hello friends, I welcome you in lecture number 8 on hypothesis testing. In lecture number 7, we have discussed about two sample Z test. We have seen that how we can apply two sample Z test for testing the difference between two population means. And we recall that if we consider the null hypothesis, that suppose two population means are equal, then under this null hypothesis two sample Z statistic is given by Z equal to x bar minus y bar minus mu1 minus mu2 divided by square root of sigma 1 square over n1 plus sigma 2 square over n2. And because we assume that null hypothesis is true, we will have x bar minus y bar divided by square root of this quantity. Here we are familiar with all these notations that sigma 1 and sigma 2 are population standard deviations, n1 and n2 are size of two samples, and this x bar and y bar are sample means. So whenever we are considering random variable, we will use uppercase letter, and for value of random variable we will use lowercase letters. So with this in mind, we consider one example on two sample Z test, and we make this remark also in earlier lecture that whenever this sigma 1 and sigma 2 are unknown, then we can replace them by sample variances or sample standard deviations, and in that case the corresponding Z statistic will look like this. And here we have made certain assumptions that we are selecting the samples and both the samples are random samples, and both the samples are independent, and whenever sample sizes are large, that is n1 and n2 both are 30 or bigger than 30, then we can apply two sample Z test. Some author consider this boundary as 40 also, so that is also valid. Different authors consider different boundaries for large and small samples. So some author consider large samples which are having sample size greater than 40. Some are considering sample size is greater than 30 as large sample. Some are considering 50 also. But we will consider the samples as large if their sample sizes are 30 or bigger than 30. And if we have large samples, then this random variable Z given by this formula is approximately standard normal random variable, so that we can use that standard normal distribution to check whether our hypothesis is true or not, or we can reject the null hypothesis, or we cannot reject the null hypothesis. So with this in mind, we try to answer this question which was asked in GTU Summer 2021 exam. First we understand what is this question about. You are working as a purchase manager for a company. The following information has been supplied to you by two manufacturers of electric bulbs. So there are two brands or companies for electric bulbs, and we have data for both the companies of electric bulbs that they are providing two samples of same size. That is, company A is providing 100 bulbs, company B is also providing 100 bulbs, and this is the information which we have obtained from the manufacturers of both the companies. For company A, average life of electric bulb in hours is 1300 hours, and standard deviation for that sample from company A is 82 hours. Similarly, average life in hours of electric bulbs provided by company B is 1248 hours and corresponding standard deviation is 93 hours and sample sizes are same. So we are given two samples. We can assume that both the samples are independent. The two manufacturers have no relationship. They are providing their data independently. So we can assume that both the samples are random and independent. And sample sizes are 100. So we can apply two samples Z test. Both are greater than 30. And we can consider this as mean of company A, mean of this sample from company A, so that we can denote by capital X suffix A, X bar suffix A, and this we can denote by X bar suffix B. Similarly, this is sample standard deviation corresponding to company A, so that we can denote by S suffix A, and for company B we use the notation S suffix B. This is sample size for company A and here N suffix B. This is the given information for two samples which we have taken from two companies. We can consider the bulbs of company A as one population and bulbs manufactured by company B as another population, and they are giving us samples of size 100 and corresponding averages, corresponding means or averages are given and standard deviations are given. Now using this information you have to decide as a purchase manager that which brand of bulbs you are going to purchase if you desire to take a risk at 5% level of significance. That means alpha is given as 0.05, which is level of significance. So you are getting this information from the two manufacturers of electric bulbs from two companies, and based on this information from this two sample data, you have to take the decision that which brand of bulbs is superior, so that you can purchase that brand of bulbs. So what we can do is we have two samples of electric bulbs from two different brands, and we can assume that here you can see that mean life in hours for company A, for sample from company A is 1300 hours and this is 1248 hours. So from this we may have the idea that the brand A might be superior to the brand B. So from this mean life of electric bulbs we can make the claim that brand A is superior to brand B. So from this we make the claim, or we assume that suppose this is the picture from this information that company A is superior to company B, or we can assume that because for sample from company A is having more mean life of electric bulbs as compared to company B, we can from this information we can predict that electric bulbs of company A might be superior than electric bulbs of company B, or we can assume that if we consider the mean life in hours for both the populations, suppose mu suffix A denote the mean life in hours of all the electric bulbs of company A and mu suffix B denotes the mean life in hours of all the bulbs of company B, and we are given sample means X A bar and X B bar. This is given, and from this given information we observe that this mean life is more as compared to this. So depending on this information we may assume or we claim that population mean for company A is bigger than population mean for company B, or we can say that electric bulbs of company A has more mean life as compared to electric bulbs of company B. So this we consider as our claim, and we want to check whether our claim is true or not at 5% level of significance. So for that we will consider the two sample Z hypothesis test, and we know that whatever we claim that goes into the alternative hypothesis. So our alternative hypothesis will be that mean life of electric bulbs from company A is more than the mean life of electric bulbs from company B. This is going to be alternative hypothesis, and null hypothesis is that both the population means are equal, that is there is no difference between the mean life of electric bulbs of both the companies, and we have to test this null hypothesis at alpha equal to 0.05 level of significance. And suppose our decision is that we fail to we reject the null hypothesis. Suppose our decision is to reject the null hypothesis, then that means our claim is correct, that mean life of electric bulbs of company A is bigger than mean life of electric bulbs from company B, and therefore we can decide to purchase electric bulbs from company A. Now once we decide alternate and null hypothesis, we have to decide the corresponding test for hypothesis. So here we can see sample sizes are 100 for both the samples, then both are greater than 30. That means we have large samples, therefore we can apply two sample Z test, and as I discussed, two sample Z statistic is x bar minus y bar divided by square root of s a square divided by n suffix a. Okay, this I denote by x bar a and x bar b, and here this sample variance for company B divided by sample size of company B, and here we have this minus mu A minus mu B, and we are considering this Z test under the assumption that null hypothesis is true. Therefore this will be considered as 0 if we want to test this against this null hypothesis. And now we are having all these values that we will substitute here, and we will find out the calculated value of this Z statistic. After that we will compare it with tabulated value of Z. For that we take the advantage that this capital Z is a standard normal random variable, therefore its distribution is in this form, bell shaped curve, and it has mean equal to 0. So we consider values of Z here, and we are testing at alpha equal to 0.05 level of significance, and you can see our alternative hypothesis is mu A greater than mu B, that is it is one-sided test. This is one-sided test or one-tailed test. So because mu A is greater than mu B, we can consider it as right-tailed test, and alpha is 0.05. So suppose I consider this area as alpha equal to 0.05, then this value is Z alpha. So what is meaning of this? If alpha is 0.05, and this means probability that if we consider area to the right of Z alpha, then that area is 0.05, and we are interested in the value of Z alpha such that this condition is satisfied. Now we know that probability that Z greater than Z alpha can be written as probability that Z is less than or equal to Z alpha, that is 0.05, and therefore probability that Z is less than or equal to Z alpha if we consider this on right hand side, we have 1 minus 0.05 and that turns out to be 0.95. So now we have to decide the value of Z alpha such that area to the left of Z alpha, this area is 0.95. So this we can decide using the cumulative normal probability tables for standard normal random variable. You can see this table here. These are the tables for standard normal curve areas, and here we can see these values in the table are areas to the left side of Z, and we are interested in the area which is equal to 0.95. We are not interested in the area, we are interested in the value of Z such that area to the left of Z alpha is 0.95. So for that we will search for 0.95 area in this table. Here you can see we have all these values are significance levels, and here we have values of, no, these are not significance levels, these are the values of Z, and we have to search for 0.95 in this table, and then from that we will be able to decide the corresponding value of Z alpha. So I have to search for 0.95 here. So here I have 0.9564, this is the line, here 0.9505, and here I have 0.9495 and 0.9505. So these two values are near to 0.95 and they are in the row corresponding to Z equal to 1.6. So what I can do, I can find out the value corresponding to these two values in this column. I have to go up to this. So now I can say that I have two values for this 1.6 and plus 0.04, that is 1.64, and 0.9505 corresponds to 1.65, and I have to take average of these two as my value, which is Z alpha. So Z alpha is average of 1.64 and 1.65, that turns out to be 1.645. So in this way we decide the critical value of Z, which is Z alpha. We are doing this process, we are interested in the value of Z alpha such that probability that Z is less than or equal to Z alpha is 0.95. This is nothing but area values in this table. So what we are doing, first we try to search for 0.95 in this table, and we find that these two values are very close to 0.95. So from this we find out the value of Z corresponding to these two values. Corresponding to 0.9495 I have 1.64, and corresponding to 0.9505 I have 0.05, and if I add it to 1.6 I have 1.6. So average of these two is Z alpha, and here alpha is 0.05, that means I have to consider Z 0.05 equal to 1.645. So once I decide this value Z alpha, which is Z suffix 0.05, that turns out to be 1.645. So this is the critical value of Z, and after finding critical value of Z, we have to compare that critical value with this calculated value of Z statistic. Now if this value value of Z statistic is bigger than Z alpha, that is critical value, that means suppose value of test statistic is somewhere here, then we will reject our null hypothesis. The area to the right of Z alpha or the region to the right of Z alpha is called rejection region. So if our value of test statistic falls in the rejection region, we will reject null hypothesis. But suppose value of Z is less than Z alpha somewhere here, then this area is non-rejection region. So if Z is less than Z alpha, we will fail to reject null hypothesis. If Z is greater than Z alpha, we will reject null hypothesis. So this is the criteria for this two sample Z test, and we have one-sided test here or one-tailed test. So if we have value of test statistic which is to the right side of Z alpha, that is Z is greater than Z alpha, we reject the null hypothesis, and if Z is less than Z alpha, we cannot reject the null hypothesis. So now what is remaining is we have to calculate this value of Z, and whatever I have discussed here, that I have written systematically here. First I have written the data for two samples. We have two samples from company A and for company B. So for company A I have used the suffix A. So we are given that mean life in hours for bulbs of company A is 1300 hours for this sample. Standard deviation is 82. Similarly for company B, mean life is 1248 hours. This is 93 hours and sample size is same. And we want to take decision that which brand we will take decision to purchase. So from this we assume that suppose brand A is superior to brand B, that means population mean life of electric bulbs from brand A is more than the mean life of bulbs from brand B. So from this data we claim that suppose this is true. So depending upon that claim we decide alternate and null hypothesis. So whatever we claim that goes in the alternative hypothesis, and negation of alternative hypothesis, that is there is no difference in the mean life of electric bulbs, is in null hypothesis. So this is the hypothesis settings. We have to first set null and alternative hypothesis. Instead of writing in this way, we can write in this way also, that mu A minus mu B equal to 0, mu A minus mu B is greater than 0. And because we have one-sided alternative, we will apply one-tailed test. Level of significance is given as alpha equal to 0.05. It is given that we are taking a risk at 5%. That means we will consider alpha equal to 0.05. And both the samples are large, their sizes are 100. So we can apply two sample Z test, and the test statistic formula is Z equal to x bar A minus x bar B minus mu A minus mu B divided by square root of variance of sample A divided by sample size of sample A, variance of sample B divided by sample size of second sample. And we want to test that null hypothesis which is mu A equal to mu B. So in the next step we will put this equal to 0 and we will substitute given values of all these quantities. So we are given that x bar A is 1300, x bar B is 1248. Similarly, sample standard deviation for company A is 82, for company B it is 93, and sample size is same 100. So we simplify all these things using scientific calculator, and we find that the value of Z statistic from the given sample data turns out to be 4.194. Now what we can do is we can decide the corresponding critical value for alpha equal to 0.05. So for that we know that because sample sizes are large, we know that this z is a standard normal random variable, therefore its distribution is standard normal distribution. So it will look like this bell shaped curve. Here I have taken values of z on real axis, and we know that if we consider this value as z suffix 0.05, then this area is 0.05 and area to the left of this has value 0.95, and if our test statistic exceeds this value, we reject null hypothesis. If test statistic is to the left of this value, we cannot reject the null hypothesis. So from this we know that probability that z is greater than z 0.05 is 0.05. Therefore probability that z is less than or equal to 0.05 is 0.95. And as I discussed, using standard normal cumulative probability table, I find that this value of z is 1.64 plus 1.65 divided by 2, that is 1.645. So this is the critical value of z, 1.645, and test statistic has value 4.194. So somewhere here suppose. So we can see the calculated value of z using two sample z test exceeds this value 1.645. Therefore we are in the rejection region. Here calculated value of z is 4.194 and critical value of z is 1.645. Therefore capital Z is bigger than z suffix 0.05. This means the null hypothesis must be rejected. And what was the null hypothesis? Null hypothesis was that population means are equal. That means mean life of electric bulbs of both the companies are same, but that we are rejecting. That means our claim is correct. Our claim was that mean life of bulbs from company A is more than that from company B. So hence we are going to purchase bulbs from brand A or from company A, because this claim is true at 5% level of significance. So in this way we can easily compare two samples or two populations. If we are given random samples from those two populations, depending upon the data from those two random samples, we can compare two population means. So this two sample Z test is applicable if sample sizes are bigger than 30. We have independent samples and samples are random. We are randomly selecting two samples from two populations, and by considering the null hypothesis that there is no difference between the two population means, we can set our alternative hypothesis depending upon the given problem, and we can make the decision about the difference of two population means. So we will have this type of situations in different problems. In this problem we have used this right tailed test. Sometimes we have left tailed test or two-sided test. So all you have to remember is that the formula for two sample Z test, and it is easy to remember: x bar minus y bar minus mu1 minus mu2 divided by variance of sample 1 divided by size of sample 1, variance of sample 2 divided by size of sample 2. And if we want to test this null hypothesis, this is going to be 0, and using level of significance we will decide critical values of Z, and then we will compare this calculated value of Z with critical value of Z. So for one-sided alternatives, if we are having right tailed test, Then we reject null hypothesis if z is greater than z alpha. If we are having left-tailed test, we reject the null hypothesis if z is less than minus z alpha. And if we have two-tailed test, we reject the null hypothesis if z is greater than z alpha 2 by 2 or z is less than minus z alpha by 2. If you remember, we have discussed all these things, all these criteria for rejecting or not rejecting null hypothesis in lecture number 1 to 6. The procedure for hypothesis testing is exactly same which we have made in lecture number 1 to 6. The only difference is in lecture number 1 to 6 we are discussing sampling distribution for one sample only. Here we are discussing sampling distribution for two samples, and we are taking sampling distribution of x bar minus y bar, that is difference of means. So that is the only difference, and that difference makes the formula for z test different from this z test for single sample. Here the formula was x bar minus mu divided by sigma over square root of n if we have single sample. But here we are having two samples and we are taking sampling distribution of the difference of two samples. So here the formula takes this form, but it is easy to remember, it is analogous to this formula. So this is the only difference. Otherwise the method of finding critical values is same. What we are doing is we are considering this normal distribution, and using the cumulative standard normal table we are able to decide z alpha. If we have two-sided alternative, we will have z alpha by 2. So this is going to be negative. So it is very easy to conduct hypothesis testing provided that we have understood all this terminology clearly. So this is all about this session. In the next session we will discuss one more problem on two sample z test, and I hope you like this session. Thank you very much.